Okay, Assalamualaikum warahmatullahi wabarakatuh. Sehafiz, my name is Nurfatan Kila binti Azmi and my metric number is 231302502 from Electronic Network Design. So today I would like to present about my mini project, which is online voting system. So the challenges and the prerequisites. So the first challenges is traffic peaks. The voting system must handle sudden spikes in traffic, especially during the final evening of the competition when millions of votes are expected. This requires a scalable architecture that can dynamically adjust resources to meet demand. The second is immediate data processing. Real-time processing of votes is crucial to ensure accurate and timely results. Delay in processing could impact the integrity of the competition and viewer engagement. So the third is security concern. With a high-profile event like a televised talent competition, security is paramount. Protection against DDoS attacks, data breaches, and unauthorized access is crucial to maintain the integrity of the voting process. So for the prerequisites, the first is scalability. The voting system should be able to scale horizontally to accommodate varying levels of traffic. This involves the dynamic allocation and the allocation of resources based on demand. Second is cost effectiveness. As the system needs to handle occasional spikes in traffic, cost effectiveness is essential. Utilizing resources efficiently and only paying for what is consumed is crucial to managing expenses. The third is operational efficiency. Automation of processes such as scaling, monitoring, and database management is necessary for operational efficiency. This ensures that the system can run smoothly without constant manual intervention. For the last is security measures. Implementing robust security measures, including encryption, access control, and regular security audits, is essential to protect the voting system from potential threats. So this is my architectural diagram and system component. So here it is. I use elastic load balancing (ELB). So for the purpose is ELB is positioned at the forefront of the architecture to distribute incoming traffic across multiple EC2 instances. This ensures a balanced load and improve the system's availability and fault tolerance. For the configuration, ELB is configured with health check to monitor the status of EC2 instances. It supports SSL termination for secure combination and evenly distribute traffic to maintain optimal performance. For EC2 instances, I use because EC2 instances are the core compute resources handling the voting request. Auto-scaling is employed to dynamically adjust the number of instances based on traffic patterns, ensuring scalability and efficient resource utilization. For the configuration, instances are launched within an auto-scaling group, allowing for automatic scaling in and out based on defined policies. Instances utilize the specified T2 and T3 instances type within the AWS Sandbox environment limitation. So I also use auto-scaling because to ensure the system can handle varying loads during different phases of the televised talent competition. During the voting system, it dynamically adjusts the number of EC2 instances based on predefined scaling policies, maintaining optimal performance and resource utilization. For the configuration, policies are set to scale out when traffic increases and scale in during periods of lower demand. So this ensures that the system is both responsive and cost effective. So I also use Amazon RDS For the purpose is Amazon RDS provides a managed relational database service for storing voting data securely. It ensures data's integrity, availability, and scalability for the online voting system. Configuration is the RDS instance is configured with a support database engine, which is MySQL, and resides within the same virtual private cloud VPC for secure and efficient communication with EC2 instances. So the advantages of the architecture is, first is scalability. So the system can seamlessly handle varying levels of traffic by dynamically scaling resources. The second advantages is because the high availability. So ELB and auto scaling contribute to resilient and fault tolerance architecture. So the third is security. VPC ensures secure communication, and AWS services are configured with security best practices. So this architectural design ensures a scalable, load balanced, and resilient online voting system capable of efficiently handling the substantial traffic demands during the televised talent competition. Each AWS service plays a crucial role in contributing to the effective management of the voting system. So next we are moving to the result, which is how I create a voting system. So for the step 1, I create a VPC. So my VPC name is a Fatin Akila mini project, and for the IPv4 CIDR block, I choose 10.1.0.0/16. So for here, this is the setting net gateway. As we can see, the number of public subnet is 2. The number of private subnet also 2. So public subnet CIDR block, I choose 10.1.0.0/24. The second is 10.1.1.0/24, and for the private I choose 10.1.2.0/24 and also 10.1.3.0/24. So here is the confirming VPC, public and private subnets, route table, and network connection. So this is the creation VPC workflow success. So here is the proof with my VPC Fatin Akila mini project, and the state is available. So the second step is to create a VPC security group. So my VPC security group is web security group mini project. So the step 3 is create a DB subnet group. For my DB subnet group name is DB subnet group mini project. For the description, I choose DB mini project subnet group, and the VPC I choose my VPC, which is Fatin Akila mini project VPC lah. So next is I add the subnet. I choose US is 1A and US is 1B as the availability zones, and the subnets is I choose the whole public and subnet, and also the private subnet. Okay, so here is the subnet selected that I choose. So Next is step 4, which is create an Amazon RDS DB instance. For create an Amazon RDS DB instance, I choose standard create, and then I choose my SQL. For the templates, I choose dev test and single DB instance for availability and durability. And for the setting, DB instance identifier, I rename it as the database Fatin Akila. And for the master username, I rename as Fatin Akila. For choosing burstable, I choose burstable class and dbt3 medium under instance configuration. And for the storage type, I choose general purpose SSD GP2 and allocated storage. I put 100 GB as allocated store. So the next is choosing mini project VPC. Under VPC section is connectivity. So then I rename the database name as Fatin Akila and uncheck both automatic backups and encryptions. So here is the connection details for my database Fatin Akila, which is my master username is Fatin Akila, and the master password I put lantak02. And this is the summary of my database. So next, for the step 5, I launch a web server instance. For my name, I put voting system server. I create an instance name voting system server with choosing Amazon Linux 2023 AMI. And for the instance type, I choose T2 medium and the key pair as for key. And this is my network setting. I choose my VPC as a VPC required. And for the subnet, I choose subnet public 2 as a subnet, and auto assigns public, I choose enable. And for the common security group, I choose web security group mini project. And both instances are running and the status checks are both passed for my voting web server. So next is I create image and display AMI ID. So I successfully creating an image and display AMI ID. So next is I create a load balancer. So here is my load balancer. I choose a target type, instances, and listeners and routers. I choose HTTP 80 port, and also for the default action I choose Fatin group. And this is my successfully created Fatin Akila group as a target group. And next is I choose for load balancer type, which is application load balancer. For the basic configuration, for the load balancer name, I put Fatin ELB, which is my name. And the scheme is internet facing, and the IP address type is IPv4. For the network mapping, I put my VPC, which is Fatin Akila mini project. And this is the mappings. I put subnet public 1 and also the subnet public 2. And for the security group, I choose web security group mini project, which I have created before. And for the listeners and routers, I choose Fatin Aquila Group, and then application load balancer has been successfully created for Fatin ELB. So next is for the step 7, I create a launch template and auto scaling group. For the launch template name, I put Fatin config, and I enable the provide guidance to help me set up a template that I can use with EC2 auto scaling. So for the application and OS images, I choose my AMIS owned by me, and for the instant type I choose T2 micro, and key pair I choose Voki as usual. And for the network setting, for the subnet I choose don't include in launch template. For the firewall, I choose select existing security group, and for the security group I choose my web security group mini project, and I enable detailed CloudWatch monitoring under advanced details. So this is my successful launching the template for mini project configuration, which is Fatin config. So next is I'm creating an auto scaling group. My name for auto scaling group is Fatin auto scaling. For the launch template, I put Fatin config, and for the network info, I put my VPC, which is Fatin Aquila Mini Project VPC, and the availability zones and subnets I put private 2 and subnet private 2, and also subnet private 1. And for choosing mini project and for load balancing, I tick attach to an existing load balancer and select let group existing load balancer. For the group size, I put desired capacity for 2, minimum desired capacity 2, and for the max desired capacity is 9. For choosing target tracking scaling policy, and rename it as Fatin scaling policy, and for the target value I put 60. So here is the adding text with the key as name and the value as Fatin instance, and this is me done creating auto scaling group, which my name Fatin auto scaling group. So here is me verifying 2 new instances. Name is Fatin instances, and the instance state is running, and status check is also passed. So here is my connectivity and security for my database. This is my endpoint. So that's all from me. Thank you.